Hi students, welcome to class. Today we're going to take a look at the law of sines and law of cosines in a mixed situation. In other words, when we have to decide whether we're going to use the law of sines, which we learned a couple lessons ago, or the law of cosines, which we learned in the most recent lesson. And so let's take a quick review of the law of sines and the law of cosines. And remember, the law of cosines, there was two different versions. Now, the law of sines, which is most often written like this, sine of A over A equals sine of B over B equals sine of C over C. But occasionally you'll see that written with all of those fractions flipped and the sides on the top and the sine of the angle on the bottom. But the law of sines, remember, there were certain circumstances when we'd use that, but mainly the way that you could tell kind of at a glance on the triangle is you would use the law of sines when you had an angle side pair where you knew both values. Like, for instance, if we knew angle A was, say, like 70, and then the side across from it was like 6. That would be an angle side pair where we knew both of them. Or, maybe we didn't know the angle, but we knew the other two angles in the triangle, so we were easily able to figure out what that third angle was, and then knowing that angle side pair, we could use law of sines. Now, we talked about the law of cosines with really two different formulas. And the law of cosines is oftentimes stated the way you see here, three different versions, just basically from the three different sides of the triangle's perspective. But just for the sake of remembering, because, again, most triangle sides aren't even really labeled as ABC, I just choose to look at the one that looks most like Pythagorean's theorem. C squared equals A squared plus B squared minus 2AB cosine of C. And then we just call C, the side C, whatever side we're looking for. And that was the one that we used when we wanted to find sides. So we could label this as the one for sides. And then if we want to find an angle, we just rewrote this formula. And that's not typically one you'll see given in a textbook or whatever, but basically just taking and solving for the cosine of C part. And that turned out to be this formula. Cosine of C is equal to C squared minus A squared minus B squared, all divided by negative 2 times A times B. I'm going to rewrite that negative sign because it doesn't really stand out very well. Hold on. And that was the one that we used if we wanted to find an angle. And so our final step in that process, once we figured out what the numerator and the denominator were, was to take the inverse cosine. And again, that one is going to be used to find angles, but in order to do so, you'd have to know all of the sides in the triangle. So that's called the side condition. And so when they say use when given, like they usually want you to state like side, side angle, side, and law of cosines is used when you have side. In other words, you know all three sides, or you know side, angle, side, you know two sides and the angle between them. And you just choose whichever one of these is appropriate if you're finding sides or if you're finding angles. So this lesson really is just a review of the prior two lessons. And it's really kind of just now you having to figure out which of these laws will I have to use. And, when you are solving in triangles, you're going to have to make the decision, is it law of sines, is it law of cosines, or possibly maybe even, is it one of the trig ratios, SOHCAHTOA or TOA? And if you have a right triangle, that's always what you want to go back to. But in the case of obtuse triangles or acute triangles, which are predominantly what you're going to see here, it's going to have to be one or the other of these two. So taking a look at example 1, our first decision is to decide which sine or cosine law are we going to use. And so that's these little boxes are for, to check off which one you're going to use. And so what I do is I kind of look around the triangle and I just look to see, do I have an angle side pair that I know both of? And I do not. So my process is really to figure out, can I use law of sines? And if I can't, then like my law of cosines is the backup plan. It's like, that's plan B. So I have this side I'm looking for, and I know the angle across from it, and I know this side but not that angle, and I know this side but not that angle. So yeah, law of sines is out. Can't do that. And if you really kind of focus on what's actually given, you actually have this side angle sides condition, because see how we have the two sides and the angle that they make, and so that's clearly the law of cosines. And we're trying to find a side, so we'll use the side version. So we could call the side x, so that's x squared is going to be equal to the sum of the squares of the two sides, so 9 squared and 19 squared, and then minus 2 times the product of those two sides and the cosine of the angle, which is 39 degrees. And remember, with those law of cosine ones for sides, it's actually pretty easy just to do this all in one step, and so you could just go straight to taking the square root of that entire thing. Just make sure that's all under the square root in your calculator, and you'll know the side right away. Just you won't have to worry about taking square root if you do it all at once. And that turns out to be approximately 13.2746, but they wanted us to round to the nearest tenth, so about 13.3, which again, that's a very reasonable length for the type of triangle that we have here. So 13.3 is the length of that side. We use the law of cosines. So taking a look at the next example, so again, we want to assess, do we have an angle side pair? Well, directly I do not have an angle side pair. I mean, I don't have an angle that's across from the one side that I do have. I have this side that's 30, and if I knew the side across from that, then I would know an angle side pair, or if I knew the sides across from the angles I do know. But because I know those two angles, and I know that the sum of the angles in a triangle is 180, I can easily figure out that that missing angle is 49 degrees. So that's going to direct us towards the law of sines. And so when we set up our law of sines, we would start with the pair that we know both of. So I could say the sine of 49 degrees divided by 30, the side across from it, must be equal to, well, they want me to find x, so I'm going to pair up these two together. So that's the sine of 54 degrees over x. And when we use the law of sines, we're always going to do the cross products. Well, sometimes we do the cross products, and for finding an angle, then we do an inverse sine, but because in this case we are just trying to find a side, we're just going to do the cross products, and that'll give us our answer. So that gives us 30 times the sine of 54 on the one side, and then on the other side, x times the sine of 49. And so to get x isolated, we're going to divide by the sine of 49. So dividing by the sine of 49 using my calculator, and I'm just going to pause now, and you can, if you'd like to as well, and calculate that yourself. See what we get. And I got approximately 32.2 for that missing side. And again, looking at the other given side of 30, that is across from a 49 degree angle, that's right in line, because 32 being across from a 54 degree angle makes complete sense. So let's go ahead and move on and look at question number 3. So question number 3, again, we have to decide which law are we going to be able to use, if either. I mean, sometimes these aren't solvable. There might not be enough information given. But I can see there's that angle side pair. So boom, got that. I know that means law of sines, and I'm going to start with my pair that I know both of, sine of 112 over 18. And I'm actually looking to find an angle this time. And so when I match the other pair up, which would be the sine of, well, I don't know the angle, that's what I'm looking for, over 8. I want to remind you about the what we call the ambiguous case. So that's when we use the law of sines to find an angle, there's always this potential that another angle could exist that would make a different triangle, but also work with the given values. And so we always have to keep that in mind, but we do start off just the same as far as how we solve. We're going to take the cross products, and that's going to produce 18 times the sine of x is equal to 8 times the sine of 112 degrees. if we divide by 18, and I mean, you could figure out what this whole thing over here as a decimal is, but really it's not necessary on our calculators because it does multiple operations. We could just go ahead and do this all at once, because now the next step is, once we cancel out that 18 on the side, we're going to take the inverse sign. So if we go ahead and take the inverse sign of that whole amount, and again, you can feel free to work and should be working these along on your calculator just to make sure you're entering everything correctly with the parentheses where they need to be and all. So I put a inverse sign, and then everything else is going to go inside the 8 times the sine of 112. I'm going to close the parenthesis on that, divided by 18, and then close the parenthesis on the whole thing. And that came out to be about 24.3 degrees. Okay, so write that a little darker. So 24.3 degrees is is one of the possibilities. Now the other possibility is there could be the supplement to that. Now the supplement to 24.3, let's see, so 180 minus 24.3 would be 155.7 degrees. Now if we look back at the triangle, there's no way that this is going to, this 155.7 could possibly be the value of x, not just because it's what the triangle looks like, because remember these drawings are reference only, but because there's a 112 degree angle in the triangle, this would just be simply too big, and that leaves just the 24.3 degrees as an option. So sometimes you're going to get 2 possible answers here, and sometimes you're going to get just one. And we've even seen scenarios where it's not a possible triangle, like this just won't work, and there is no possible angle that would work given the circumstances. Okay, let's go ahead and take a look at example 4 then. Now this time you notice we have all 3 sides, so that should be a dead giveaway that that's going to be the law of cosines. And we're going to have to use the law of cosines for angles. So we're trying to find an angle here. The angle we're looking for is across from the side that's 7 units long. So remember, when we use the law of cosines for angles, we'd say the cosine of, well, the angle is called x. And when we use that formula, the side across from the angle we're looking for has to go in first. It's like basically called C. And then it only appears just in that spot. Otherwise, the 6 and the 5 go in the other 2 spots. So it would look like this: 7 squared minus 6 squared minus 5 squared, all over negative 2 times 5 times 6. And again, the 5 and the 6 can be reversed position. It doesn't really matter in both cases. So this one you want to be careful to do in separate steps. So first thing I'm going to do is figure out what that numerator is. 7 squared minus 6 squared minus 5 squared. Turns out to be negative 12. And then the denominator, negative 2 times 5 times 6 is negative 60. And so my final step is then to go ahead and take the inverse cosine. And when I take the inverse cosine of, let's see, so inverse cosine of negative 12 divided by negative 60 turns out to be approximately 78.5 degrees. And the nice part about using the law of cosines to find angles is there's no such thing as the ambiguous case for law of cosines. It is what it is. If you know the 3 sides, you'll find the angle directly. There is no other possibilities. So, that's the nice thing about law of cosines. If you can use it, is it's a very exact process with a known value. Okay, so we have all of our tools now as far as anything we need to find missing parts in triangles. We know SOHCAHTOA for right triangles. We know the law of sines and cosines for non-right triangles, and even for right triangles. I mean, you can use the laws for anything. But, what if we want to solve a triangle? So what does that mean? Well, when we want to solve the triangle, that means we want to find every missing part. So this might be where we might not just use law of sines or just law of cosines or, whatever. We might be using combinations of those things. Like we might use the law of sines to find a missing side, and then we turn around and use the law of cosines for angles to find the angles or whatever. So we might be using them in conjunction to find any missing parts in a triangle. So solving triangles, to solve a triangle means to find all missing sides in angle measures. And in this case, they want us to write all of our answers to the nearest tenth. So we'll go ahead and take a look at one of these together and then have you try a couple for some of you tries. So number 5 has a triangle called ABC. And it looks like they give us 2 angles and a side. And again, I really don't have any idea exactly what this triangle looks like given this information. So I just draw usually a random triangle and I'll just label it ABC. It's really for my reference only. And so I know that they've told me that angle A is 47, angle B is 52, and that side AC, which means that's across from angle B, would be 13. And so right away, you know I got to find all the missing parts anyway. So it doesn't really matter what I find first, but that angle is really easy to find, that missing angle C. So might as well knock that one out. And I know that it's the rest of 180. So if I take the 52 and the 47 away from 180, I end up with 81 degrees. And so I got one down. Oops. So there's one down, 81 degrees, that missing angle. That's the easy part. So I don't really need that right now, but I might need that later. So 81 degrees. So right now what I'm trying to do is, let's say I'm trying to find, let's say I call this X, and I want to find this side, which is BC. So taking a look at what I have given information that I knew for a fact, what that was given in the setup of the problem, was I knew an angle and the side across from it. So this is not a right triangle. That means I got to use the law of sines. So setting up the law of sines, I would say the sine of 52, which is across from the side that's 13, so sine of 52 over 13. Oops, my stylus is acting up. And that's going to be equal to, so if I'm trying to find this other side, I would match these up together. So the sine of 47, oops, sine of 47 degrees over X, and I'm going to go ahead and just do the cross products then. So we should be getting good at the law of sines. So that's 13 times the sine of 47 equals X times the sine of 52, and that means I'm going to have to divide by the sine of 52. So we're going to divide by the sine of 52 to get our missing first side. And that's going to give me, let's see, 13 times the sine of 47 divided by the sine of 52, and that gives me about 12.1. So BC is 12.1. So now I know that. And the final missing side, if this was, say, a right triangle, I could use Pythagorean's theorem because then I would know two sides. But now I'm back to where I started, and I'm going to have to use a law of sines or a law of cosines or whatever again. And I kind of have options now because I just found this side right here. Oops. And I found it to be 12.1. Oops. I could kind of think about this as if I didn't have these angles over here. I mean, you can just sort of ignore these, that this was 52 and this was 47. You could ignore those right there. And you could then use your two sides and the included angle and use the law of cosines. So I'm going to go ahead and put those angles back on there just because they were things that we knew. So, but again, just focusing on what I need for this particular side I'm trying to find. I'm just going to use this side, and this angle, and that's going to help me to find the side across from it. So I can just call that side, I don't know, you can still call it X, I guess, or Y, or whatever. I guess you could call it C because it's across from C. So yeah, there you go. We call it C. So that would be C squared is equal to 12.1 squared plus 13 squared minus 2 times 12.1 times 13 and times the cosine of 81. And then all I have to do then to solve that is just take the square root of that whole thing, and that should give me my final missing side, and I will have solved the triangle. So let's see, that would be the square root of 12.1 squared plus 13 squared minus 2 times 12.1 times 13 times the cosine of 81, and I got 16.3 when it's rounded to the nearest tenth. So that's the missing side. AB is 16.3, and now I know every part of this triangle. I've solved the triangle. So I'm going to go ahead and designate number 6 as a you try question. And so if you want to take a moment, pause the video, sketch a little triangle given the information, and in number 6 they're asking you to find all of the missing angles. So go ahead and pause the video now, give number 6 a try, and then tune back in so you can check to see your level of understanding and whether you're going to want to ask any questions, or if you kind of feel confident to move on and apply this on your own. So go ahead and pause now. All right, thanks for giving that one a try. I decided in my situation to use the law of cosines twice. And that's probably the easiest thing to do. Using the law of cosines, remember, gives you an exact value for your, like only one possible angle value. Whereas if you had, say, used the law of cosines first, which is what you would have had to do, but then let's say you use that angle then, and one of the sides across from it, or the side across from it, to do the law of sines, then you'd have to consider the two possibilities. And so I thought it was really easier in this case to just use the law of cosines twice. And that's typically, if you're given all three sides, I would always do that. Because that's dependable. There's just one possibility with law of cosines. So I found angle x first, and then I found angle z. Now, sometimes when you are doing these, because of the rounding and the order that you do them in, they might be off by a tenth or something, and I just would not worry too much about it. For instance, the answer key that came with the materials, they found x first, was 49.1, but then they found y next as 46.2, which then made z 84.7. But I found z second and then y. So occasionally, depending on the order, you might be off by a tenth or something, and so I wouldn't worry too much about that when you're checking answers later on with the assignments. If you're in the ballpark, you're doing something right. But so typically, if they told you an exact order to put them in, then yeah, you would have the same values. But because you get to choose what order you want to find them in, just be a little forgiving of yourself if you're off a little bit. So I feel like that the examples we've seen have really covered all the possible scenarios, and I feel like we can just, and we've got plenty of practice. I mean, if you want to practice the next two, feel free. Maybe what I'll do is I'll real quick just write down the answer so you could practice those. But remember, we will have an assignment to accompany this in our homework packet, and you'll have plenty of practice there. But I will go ahead and just, so if you want to jot these down and come back later to do a little more practice, maybe closer to the test time or whatever, just to get a few more extra practices. On number 7, the answers would be for angle D would be 49.5 degrees. And again, kind of might be off a tiny little bit. The next one would be 58.5 degrees. And then the missing side, DF, is approximately 13.4. And then going on to number 8, there's 2 angles again to find on a side. So 32 degrees, 93 degrees then for angle T, and 13.9 for the missing side, ST. So again, just maybe jot those down now, just so that if you decide to come back later to get a little more practice, you can check your answers. So that does it for this part of trigonometry, and we're going to kind of be moving into more of like a reviewing now that we've learned the special right triangles, we've learned the SOHCAHTOA and how to deal with non-special right triangles and finding parts, how to deal with acute and obtuse triangles, and really any kind of triangle with the law of sines and cosines. And then, of course, that focus, we spent time on that unit circle. So kind of look forward to reviewing, and we'll get a chance to have an assessment to test our understanding. Thanks for coming to class. Oops, I forgot. There is one other part of this lesson. So I'm so sorry. I forgot we were also going to talk about finding area of triangles. So I'm going to set up another lesson that I'll send out that just focuses on area of triangles. So we will have one more thing before we kind of try to put all this together and have an assessment. So look for one more lesson coming out on the area of triangles.